you have to take these steps, use the properties of exponents to simplify each side of the equation. Those are the rules right there behind Theo on the glass, right there. Exponent rules is what you want to use, okay? To simplify both sides or each side of the equal sign. Then you want to rewrite the equation so both sides have the same basis, okay? Then you get to drop the bases. That's the best part right here. You get to drop the bases because they're identical, okay? Then you're going to set the exponents only equal to each other and solve, okay? So let's take a look. Type 1, equations with common base. Do we have the same base? Drop them, just write out the exponents, and we get x plus 1 equals to 9. So what's x? 8. Ta-da! And then guess what? I love you guys. You have to check for extraneous. You have to check for extraneous. So how do we check for extraneous? Plug in the x that you found back into the original equation. 2 to the 8 plus 1. Does it equal to 2 to the 9th power? Yes, it does. Easy peasy, right? So this is the correct answer. There's no extraneous solutions, and we can move on. Okay? All right. Number 2 works the same way, same basis. Just put 4n plus 5 equals to n minus 7. Are we good with that? Skipping to number 3. We have to use the property. Which property among the exponential rules should I use to put the left side of the equal sign? Product. So if we have same basis and we're multiplying, what do we get to do with the exponents? So we're going to add k and k plus 2. If I add k plus k, do I get 2k or k squared?
Yeah, 2k.
2k. Because you've been doing so much multiplication and like exponents, I know it can be tricky. That's why I brought it up. If I were to add k plus 2 and keep the base 3, this is 2k, right? Plus 2. Does that make sense? Yeah? That equals to 3 to the 5k minus 1. So, do we have the same base now? Yep. So we get to drop those bases and just write out 2k plus 2 equals to 5k minus 1. How are we doing? Subtract 2k on both sides, I get 3k minus 1. Add 1 to both sides, I get 3 equals to 3k. Then I would divide both sides by 3. I get k equals 1. How do we check? There's some trading going on here. Equals 3 to the 5 times 1 minus 1. Okay. So I'm placing 1 wherever k would be and solving. Okay. So 3 to the first plus, like 1 plus 2 power. This one, that equals to 3, right? What's 3 times 3 to the third power? 3 to the fourth power, yay. 3 to the fifth power minus 1 is 4. So it's 3 to the fourth power. So do they equal each other? Yep. So that's my correct solution, real solution, and there are no extraneous solutions. Okay? All right. Do you need me to work on number 4 with you? I think I do. You want to try it and check? Product rule again. On both sides this time, you want to add the exponent. So add negative 4 plus 9. Add b plus 4 plus 2b minus 11. And write it as a single same base. 9. This plus this. Plus 4 plus 2v minus 11. How we doing? Negative. Did you get the same thing? That's what I got. Good. Check your extraneous. Yep. V equals 4. I can't squeeze in my minus 11, so I kind of wrote it down. That looks terrible. Let me see if I can fix that. Times 10 to the 2 times 4 minus 11. Let's see if they equal each other. That one's 10 to the 5th power. That one is 8. That one's 8 minus 11. So we're going to add these guys. That becomes 16 minus 11, which is 5. Yay, it works. So this is correct, and there are no extraneous solutions. Did I go too fast? Okay. All right, so that's the easy one. This is a little harder. You have to kind of think it through. You really, really, really have to remember all of your multiples as much as possible, okay? I need a base of 6 to match on this side. Is there a way that I can rewrite 36 into a base of 6 as an exponent? 6 squared. So I'm changing this one to 6 squared. Now do we have the same base? Yep. So we bring down the exponents and solve. Good. Good. So x equals 6. Check it. Six to the 2 times 6 minus 10. Does it equal 36? Let's see. 2 times 6 is 12. 12 minus 10 is 2. So does it work? Yep. So no extraneous. Okay. What can I change 8 to? Good. I was worried that you guys would say 2 to the 4th power. You guys are smarter than that. So 2 to the 3rd power equals to 2 to the p minus 7th power, right? That's easy. So what's p? 10. Okay. Check. 2 times 10 minus 7 equals to 2 to the 3rd power. Yes, it is. No extraneous. All right, what about that one? That looks weird. It's a fraction. How do we get a fraction from exponents? Yeah. Negative exponent. So since we didn't change the base, it looks like we just get to keep the base at 7, raise it to negative 1st power, and that should match 7 to the 4x plus 11th power. Okay. Drop the bases. 4x plus 11 equals negative 1. Subtract 11 on both sides. I have 4x equals to negative 12. Divide both sides by 4. X equals to negative 3. Negative 3 times, I'm checking, 4 times negative 3, then add 11. Will it equal negative 1? Yep. So I'm feeling kind of lazy, so I'm just checking the exponents because we already know the bases are the same. And since I get negative 1, this works for me. No extraneous. Okay. Now this is the tricky one, number 9. Okay. There are 2 ways to go about it, but I would rather have you guys go in a consistent direction of just changing the base to the lowest base that we see rather than changing it both to something higher. And it's gonna get confusing anyways. So 27 can be rewritten with a base of 3. 3 to what power is 27? So that third power, if I do 3 to the third power, I get 27, but that 2x plus 6 is still there. What should I do with those two? Add or multiply? You should multiply. Okay. So we have 3 to the 2x. 3 times 2x is 6x. 3 times 6 is 18. Equals to 3 to the 2x power. Same bases, drop the bases, and start solving for x. So that would give me 4x equals to negative 18. It looks like we're going to have a fraction. Are fractions still valid answers? Yep. Negative 9 over 2. When you check it, it should still work. And luckily for you, both of them have coefficient of... Oh, sorry. Just tell me. If you can't see, just tell me. I'll move it up. Okay. Both of the variables have a coefficient of what? Both of the variables have a coefficient of what? Which one's the coefficient? 2. Coefficient to a variable is the number that you multiply with the variable. So what is the coefficient of the x? 2. Thank you. And that 2 matches the denominator of your fraction answer, yes? Then you can use the fraction busting method to solve for the rest, okay? What is it, Karis? Six, 8, 6, 7, 6, 8, 6, 9. They're all part of it. You're welcome. Three, no, 27. 27 to the 2 times negative 9 over 2 plus 6. Nope, only here. And erase there. 6 equals 3 to the 2 times negative 9 over 2. So do you see that part right here, 2 over 2? I can cross them out. What do I have? Negative 9 plus 6 is negative 3. 3 to the second power gets canceled out with the denominator 2. And who's left? Negative 9. Let's see if it's equal to each other. You got a calculator, yes? What do you get? 27 to the negative third power. It should be a that. It should be a small number, but in a decimal form. What you got? You should try it in case you're punching things in wrong so you could get correction from me. 27 raised to the negative third power. What you got? Really small. So 3 to the negative 9th power. Do that one. Is it the same? No? It's different? I don't think 27 to the negative third power is 5.7. I think it should be more. 0. So Riley's is so small that it came out to 5.080526343 to the negative fifth power. Do you guys see it on your screen? Yes. Okay. What that means is it's a scientific notation. That E takes place of times 10 to the negative fifth power. So that means that we will move that decimal 1, 2, 3, 4, 5. Did I do it wrong? No, it's negative 30, right? Oh, you're supposed to bring it to the now. Yep, there you go. Okay. Figured it out. Are you good? Can I move on? Okay. We need to get to number 11. Number 11. Ready? Okay. 125 and 25 have what base in common? Is it 25 or 5? It should be 5 because 25 to the third power is not going to get you 125. 25 to the second power is not even 125. Okay, so it has to be a base of 5 for them to have it in common. 5 to the third power equals to 125. So if I were to multiply 3 times y, I would get 3y. Okay, and then 25 is 5 to the second power. So set this up. 3y equals to 2. What does y equal to? 2/3. Let's check it on your calculator. Use it to your advantage. Don't sit there and go, I can't check this because I don't know how to do this. Well, you kind of learned in the last unit. Yeah? So it should be cube root of 125 squared. Right? So what is it? It should be 25. Does it equal the 25 on the left? Right. Yep. So do we have any extraneous solutions? No. See how many times I go over that question? So do we have any extraneous solutions after you figured out it's correct? I saw people who are so confused. If your answer comes out to something that is not equal to each other, what can you say about the solution you use to check it? It is an extraneous solution. Okay? So you can't say no extraneous. If this wasn't the same, then you have to say this isn't the same. Does that make sense? And then you wouldn't say no extraneous solution. You would say there is an extraneous solution and it's that. Okay? I'm erasing it. Oops. Undo. Okay. That's easy. That's easy. That's easy. Which one should we do? Which one looks really hard to you? 19? I was thinking that too. All right, ready? Everybody needs the same base. 1/7. How do we write that as? Perfect. 7 to the negative first power. What about 49? 7 to the second power. We're going to multiply what's already there. X minus 5. And then multiply that with 7 to the x minus 9 power. 2 times x. 2x. 2 times negative 5. So we got 2x minus 10. What do I do with that and x minus 9? Add them. 2x plus x is 3x. Negative 10 minus 9. There you go. Do we have the same base? Do we have a single exponent on both sides of the equal sign? Yep. So we just set it equal to each other, negative 7. Drop the bases. Set it equal to each other. Add 19 to both sides, and I get 18. Equals 3x. Divide both sides by 3, and x equals 2. Done. Check it. We just need to get 1/7. So if you want, put 1/7. 1 divide by 7 and press enter. So you have the decimal version of it on your screen, right above it. Okay? So we just need the right side to equal that. 1/7 as a decimal form. Does that make sense? Okay? So 49, you're going to put it into your calculator. 49, raise it to 6 minus 5. So that's 1 times 7 to 6 minus 9. So that would be 49 to the negative, no, first power times 7 to the negative third power, right? What do you get? Is it the same as 1/7? Yay! If you want to do it my way, it could be done like this. 7 to the second power times 1 is 2 times 7 to the negative third. 7 to the second power minus or plus negative 3 gets me 7 to the negative first power, which is same as 1/7. You could do it that way too. Okay? No extraneous. I really hope you guys put your calculators back after today to make sure you have your calculator available to you on the day of the test. Oh, about the test. Since everybody's here. Who's missing today? Okay. Remember to tell her there's a no calculator section on the test and a calculator section on the test. So I'm giving you 2 separate sheets. When you're done with your calculator portion, I'll take your calculator, I'll take your paper, and you get to have the no calculator portion to answer those questions without it. Okay? So we'll work that out, Miss Gabby, however we can. No calculator would be like 6-4 and 6-5. Right there. I understand what a logarithm is and can change equations from exponential to log form. And I understand the laws of log and use them to simplify expressions. Yep. Huh? 16? This one? Yeah. 3 to what power is 27? 3. 3 to what power is 243? How do we figure that out without having to do 3 to the third power, 3 to the fourth power? Yeah, but what do we use? 27 has a base of 3, yes? It works every time. It's either 27 to some power or 27 has to be placed into a 3 base, right? So let me see. Oh, there we go. 27. Try 243 divided by 27. What do you get? Hello? 9. That's 2 3s, right? 3 times 3. And 27 is 3 times 3 times 3. Try 3 to the 5th power. Three to the 5th power. What do you get? It's not magic. It's just knowing your multiples. Okay, 3 to the third power gives me 27, so I multiply that with 2x. That equals to 3 to the fifth power gets me 243. So I multiply that with x minus 2. So 3 times 2 is 6x. 5 times x is 5x. 5 times negative 2 is negative 10. Does that help? Okay. Does that help, like how I did it? Okay. I know. So see if it's divisible to each other first. So that way you can figure out, okay, if I could rewrite this with base of 3, then I should be able to write this with base of 3. So you could do 243 divided by 3, and then take that answer, divide by 3, take that answer, divide by 3, and see how many times you have to divide by 3 to get to 1. You could do it that way too. Okay? All right. Are we good on this?